So, hi, welcome to the free Healthy Homes Crash Course. It's really great to have you here. I'm going to start with a quick introduction. I am Sharon. I am an architectural designer, passive house designer, and Homestar professional. And I've put this free training together because all of my knowledge in architecture and building science benefits my clients. But there's a group of people who miss out, and that's you. People who are wanting to make improvements to their home without the professionals, or with jobs so small that most professionals are just not interested. So, this is my way of offering you some help with understanding the who, what, why, and how of making your home healthy. Now, I have 15 minutes for this free training, so I'm going to touch on the three main issues that my friends and family ask me for advice on, because I'm guessing you probably have the same three things that you're looking at. Now, before we get started, I just want to remind you that the house is a system. So any upgrades or changes that you do will impact on other areas of your home's performance. Sometimes these can work against each other, so it's important to find the right balance. For example, if we have an airtight home, it's really good at reducing heat loss, but we have ventilation and moisture issues that need to be addressed. And a slightly air leaky home is not great for heat loss, and there's the issue of moisture getting trapped in the structure, causing rot issues that you might not be aware of. So we need to consider these things together and not simply in isolation. Now, the three things I'll be covering is insulation, windows, particularly around double glazing, and heating and cooling systems. So let's dive in. So insulation. We all know about insulation. Most older homes will have little or no insulation. It was only mandatory in New Zealand in 1978, and old insulation might have slumped if you've got the early stuff. So if your home is built pre-1990s, you will have little or no effective insulation. So it's a good idea to put some in. The common places are spaces in the ceiling space and under the floor. Now, there are many insulation products out there. Not all equal. We don't actually have mandatory testing to test insulation products with their claims values. There's a generic calculation that's applied to their values. So in the Healthy Homes for Homeowners course, I run through the insulation types and brands. Also, I'm an independent professional, so I'll tell you the ones that I use and recommend for my clients. Now, one big, huge mistake I see with insulation is this, people using insulation injected into their wall cavity. Now, if you're thinking about doing this, please just stop for 1 minute and hear me out. There is very little observation or regulation around the stuff. You don't need a building consent to insulate your ceiling and underfloor, but if you do need a building consent if you're insulating your external walls. Now, here's the reasons for this. One is you can create moisture, mold, and rot issues if the insulation is in constant contact with the back of your cladding, especially if you don't have any building paper, and old homes don't generally do. And insulation can block up the drainage cavities in the construction of our walls, particularly if you've got brick veneer, which again is going to trap water in your wall structure, and you will find mold growing through your wall linings over time, particularly on the north faces where it gets some heat. Now, warm, moist conditions are paradises for mold, and timber wall framing is the organic material to feed it. So it's a perfect breeding ground for it silently. Also, wall linings are used as bracing elements in our homes. So if you just remove them and don't do bracing calculations, your home structure will likely be compromised in the case of a storm or earthquake situation. So buildings in New Zealand legally have to be braced for wind and earthquake, and how they brace does depend on your home's design. So if your walls have been insulated without a consent and bracing considerations, in the event of a natural disaster, your insurer might not pay out because you have illegal building work. So in the Healthy Homes for Homeowners course, I cover the questions you should be asking anyone who says you can insulate your walls. You can. There's just a right way to do it, and then there's just the illegal way to do it, which is not going to benefit you. Okay, double glazing in windows. Now, double glazing is good, but your existing windows, particularly if you've got old timber windows, might not be able to take the weight of the glazing unit. So you do need to consider your options. Because you want to make the right decision to get maximum benefit out of your home improvements, right? In some cases, you will need to rebuild part of the window. If it's timber, sometimes you might need to just replace the whole unit. Now, we have three common materials for windows on the market: timber, UPVC, and aluminium. In November 2023, legislation caused for all aluminium to be thermally broken. That's with a plastic piece in between two aluminium skins, and at a minimum double glazed with high performance glazing. Now, what that means is most aluminium joinery companies are now set up for this. So if you want single glazing or non-thermally broken aluminium, it's going to be more expensive because it's going to do a special run. It's also a lot more poor performing. So I wouldn't bother. Timber is expensive, but it's really good for performance, and UPVC is holding its ground on the market, and here's why. So I'm going to show you quickly the thermal conductivity values for these three materials. Now, metals are really good at conducting heat. It's why our pots and pans are made of this stuff. But when you take that metal and you put it vertically into the window, the material is still really good at conducting heat. It's why aluminium needs to be thermally broken with the high performance glass. So the frame in aluminium is actually the weaker performing element, which is why you don't have to put such high performing units into timber and UPVC windows to meet the minimum code requirements. So the lower the number, the better it is for healthy homes. So timber sits around 0.13 to 0.16. It's grain and species dependent, and UPVC around 0.13. Aluminium sits at 160, which means there's a strong possibility that that surface is going to have internal condensation, much like we see on our windows if we live in an old home. So UPVC bridges the gap between cost and performance between timber and aluminium. Now, I know UPVC has a bad history with yellow, brittle plastic downpipes and spouting. We still use UPVC downpipes and spouting today. Marley, that you might all know Marley. It's a commonly used brand. The UPVC has a UV stabilizer in it. So there is a company that makes UPVC windows here in Auckland. Their offcuts actually go to Marley. So we are using and recycling it here in New Zealand. I know there is a bit of pushback about plastic and its sustainability, but there really are companies making great grounds and addressing the sustainability issues. Now, I just want to bust a myth here. Double glazing doesn't stop condensation on your home or in your home. It might reduce the condensation on your windows in winter, but glass doesn't remove moisture from your internal air. Ventilation does. So if you're double glazing to stop weepy windows, there are other things that you need to consider, because that condensation will still just keep happening. It's just not happening on your windows. If you don't have ventilation, it may well be happening somewhere where you can't see it. Now, in the Healthy Homes for Homeowners course, I cover ventilation and what options you should do and definitely do not do. There are many ventilations and HRV systems on the market. Again, legislation around these units is poor, and most of these units can actually cause more issues than they solve if they're not the right fit for your home. Lastly, heating and cooling. I mean, this is all related back to ventilation too, and insulation. So the price of our power is rising, and we all need to heat our homes in winter to some degree. So choosing energy efficient options is important. Space heating and water heating use approximately 64% of power in our homes. This is according to typical power use in a home that was compiled by Brands, which is the Building Research Association of New Zealand. So if we can get smart with water heating and space heating, we can reduce the power demand to keep the same level of comfort, or improve the level of comfort. But heating doesn't exist in isolation. Insulation, air tightness, and ventilation all play a role. So in the Healthy Homes for Homeowners course, I cover how with the right ventilation and dehumidification systems, we can lower those bills. Damp air is hard to heat in your home. Also, it's not good to breathe. So considering heating in the context with the other requirements is quite critical to making our homes healthy and affordable to live in. Now, I'm going to let you in on a little secret. Our building code, which is effectively the legal minimums which all homes have to comply with. So effectively, I call it the worst performing building you can legally build and the most unhealthy. It doesn't cover overheating in our homes at all. So all it concerns itself is with heat loss and insulation when it comes to a part in the building code called energy efficiency. So our homes are getting quite hot in summer. And I do want to bust a myth out here. I've heard people say that the western sun is stronger than the eastern sun. That simply is just a load of rubbish. What happens is when our homes overheat is that the interior of our homes, which are often shut up with very little ventilation, like in a summer's day when we're out at work, they reach their our comfort level quite quickly. But if we don't have shading over those northern and western windows, we're going to get more and more free solar gains. So it's not necessarily that the sun is stronger. It's just that we have oversaturated the level of heat that we want to get from the free sun. Our World Health Organization suggests our homes should stay constantly between 18 and 22 degrees Celsius. So 18 is the minimum they recommend. Our existing homes would fluctuate easily between 10 degrees and maybe 30 degrees, some even up to 44 degrees Celsius. So this is how unhealthy even our newly constructed homes are. And I know that's a bit of a depressing thought. So there are international standards called Passive House, and there are ways to improve these things. We just need to do the right things, not the commonly sold things and the commonly talked about things. So first of all, you need to stop that sun from reaching those particular windows, so you don't have to deal with the additional sun. Internal blinds are not going to help you. You need to stop that sun before it hits the outer pane of glass. Now, of course, glazing type does help. We cover this in the course, but that's a balancing act too. So spending more money on higher performing glass might help with overheating, but it also reduces solar gains, so you won't get those free gains in winter. So there is a sweet spot. So to help with overheating, we also need good ventilation systems that work when we need them, not just when the wind blows and when our windows are open. And I just want to point out that heaters heat air and air conditioners cool air, but they don't remove the carbon dioxide from your interior air, nor do they remove the moisture. So getting a system that acts like a dehumidifier, heater, air conditioner, and fresh air supply, that's a really smart way to create a healthy home rather than relying on a whole heap of multiple appliances. Also, if you're changing the temperature of air and not addressing the humidity of it, you run the risk of condensation because it's a little thing called relative humidity. So smart healthy homes use the free solar gains in the cooler months to reduce heating bills and stop the free solar gains in the warmer months to reduce cooling bills or stop overheating. Now, our building code relies on opening windows for ventilation. A study by Cara Rosamere, who's an architect, she's also a certified passive house designer and building scientist. She put sensors in 10 homes in Auckland for a year and monitored the CO2 levels or the carbon dioxide levels, because if we have high carbon dioxide levels, we know that we haven't got enough fresh air replacing that stale old air. And what she discovered was that our windows and doors can only be used for adequate ventilation for about 10% of the year. So I want you to think about how often you're at home, because we don't leave our homes with our doors and windows wide open. We also don't leave our doors and windows wide open when we're sleeping, and that's when we do create the most carbon dioxide because we're in one room for an extended period of time. And also how effective it would be when you're opening up your doors and windows and you're trying to heat your house. Guaranteed someone's going to tell you to shut that because they don't want a super high power bill heating the external environment of your home. There's so much more that I can go into, but I'm doing this crash course in 15 minutes. So I hope this helps you. And if this helps some of you, that's fabulous. My job is done. But if you want to understand more and get access to products and manufacturers that I recommend, get a list of questions to ask salespeople and tradespeople, and to make sure that you're making a well-informed decisions around insulation, ventilation, windows, heating systems, and airtightness, sign up for the Healthy Homes for Homeowners. I cover these issues in Home Improvement Sense and so much more depth. It's $99. It's well over an hour of my knowledge and experience, and I charge my clients much more for that. So the link for this course will be sent out for you in an email if you've signed up for this through the email link. And if you haven't got it, please reach out to me. I can happily send you the link. Also, you can find it on my website, www.smartlivingspaces.nz. So I look forward to seeing you in the course because it's really my mission to create healthy, comfortable homes for everyday New Zealanders, just one home at a time. So thank you for your time. Hopefully that was useful, and I'll see you inside the course.